Kia ora, year 10. This video is about tree diagrams in probability, and it goes along with the Education Perfect work that I've set you and some of the worksheets. So tree diagrams in probability are a really big part of this topic that you'll use right through secondary school. They come up in level 2 probability heaps and again in level 3, and obviously they get a bit more complicated. Today I'm going to start off with a really simple example, a stupid made up one about what I like having for breakfast during lockdown. So here's the problem, and we're going to go all the way back to the start of how we turn this into a tree structure and then how we answer some questions. Right, so I like Weet-Bix for breakfast, but I don't like it every day. So around 70% of the time I have Weet-Bix for breakfast. And then if I have Weet-Bix, I usually like having Milo with it. So if I have Weet-Bix, then 80% of the time I will have a cup of Milo with the Weet-Bix. But if I have something else, I don't usually want Milo. And I just have Milo 10% of the time when I'm not having Weet-Bix. So you can see straight away in here that there are two things going on, right? There's the probability that I'm going to have Weet-Bix, and then there's the probability, the chance that I'm going to have Milo. And there's a relationship between those two things. So that means that we can use a tree diagram to set this problem up. Now, the first thing I'm going to put in there is, do I have Weet-Bix or not? I'm doing it that way around because the stuff I've been told about Milo all depends on whether I'm having Weet-Bix or not. Usually in year 10, you'll get given the tree diagram and you just have to chuck in some numbers and answer some pretty simple questions. But I want to show you how we know how to set it up. So here, the first branch is about Weet-Bix. So I put Weet-Bix on here. This is, do I have Weet-Bix? And I have Weet-Bix about 70% of the time. So I'm going to write that as a decimal, 0.7. Now, I'm not told what I have on the other days, so we're just going to say not Weet-Bix, and we use this dash notation, right? Remember, this means the complement of the event. So not Weet-Bix, and that must be 30% of the time, right? Because those two numbers have got to add up to be 1. Now let's look at the second bit of the tree. Do I have Milo or do I not have Milo? Big decision, right? So if I've had Weet-Bix, I usually like to have Milo with it. So 80% of the time that I have Weet-Bix, I have Milo. So that's going to be 0.8, and that's Milo there. And that means that the rest of the time I must be not having Milo. Maybe I'm having coffee, maybe I'm having water, or maybe I'm not having a drink. And then if I have something else for breakfast, I only have Milo 10% of the time when I'm not having Weet-Bix. So down here, we're going to draw another bit of tree. So Milo now is only 0.1. And here, not Milo is most of the time, so that's going to be 0.9. So that's how we set the tree up. Now, let's look at the kind of things we might be able to figure out with this. So here are just 4 questions. What's the probability that I have Weet-Bix? And we're going to write that as P bracket Weet-Bix, and I'm going to just use W for Weet-Bix. Next, the probability that I have Milo and Weet-Bix. I'm going to write this like this, P of W, and I'm going to write and M. Now, sometimes you'll see this horseshoe meaning and I'll use that a little bit in class. That means the intersection of two things. It's fine just to write and. I just want you to recognize this now. The probability that I have no Weet-Bix and no Milo. So that's no Weet-Bix and no Milo. And lastly, the probability that I have Milo. So let's go back to the tree and figure out how we can work out each of these things. And I think it's easy to think about these with percentages, right? So on 70% of days, I'm going to have Weet-Bix. And then on 80% of those days, I'm going to have Milo. So if we think about it, that if we've got 100 days, we're going to have Weet-Bix on 70 of them. And then on 80% of those days, we're going to have Milo. So we want 80% of 70 if we're looking at 100 days, right? Which is 56 days. So 56 out of 100 gives me 0.56. Now, we're not going to think about it with percentages all the time because very quickly we can see that what we've done to find the probability of having Weet-Bix and Milo is that we have just multiplied those two numbers together, okay? And that gives me 0.56. And we're going to do the same thing for each thing in the tree, right? So remember, these are called our outcomes. And all of that first EP module went through the language of probability. So the outcome here is for Weet-Bix and Milo. The next one, Weet-Bix and not Milo, will be 0.7 times 0.2. So that's 0.14. And notice that, of course, these have got to add up to the probability of having Weet-Bix, right? Because I'm either having Milo with the Weet-Bix or I'm not having Milo with the Weet-Bix. On the next one, we do the same thing. So the probability of not having Weet-Bix and having Milo will be 0.3 times 0.1, which gives me 0.03. And then the next one, 0.3 times 0.9 will be 0.27. So that's the first thing that I do when I see a tree problem, usually, is that I work out those those outcome probabilities, right? So remember, an outcome is one possible thing that can happen. An event is when we start putting several outcomes together, right? So the probability that I have Weet-Bix is an event, because I could have Weet-Bix with Milo or Weet-Bix with Milo, no Milo. In this case, finding the probability that I have Weet-Bix is really easy when I look at that tree diagram. And that's because Weet-Bix is the first thing in the diagram, right? So straight away when I look at the diagram, I'll just take out some of the extra circles and underlines. You can see the probability that I have Weet-Bix is simply 0.7. Okay, so the probability of having Weet-Bix is 0.7. Now, what about these next ones? The probability that I have Milo and Weet-Bix is going to have two things in it. So let's shrink this a bit. So the probability of Milo and Weet-Bix, oh, this has only got one thing in it. This is still a nice, easy one, right? So Milo and Weet-Bix is this one here, right? So we've gone 0.7 times 0.8 there, and we've lost our tree branch. There we go. So 0.56. Now next, the probability that I have no Weet-Bix and no Milo. Well, no Weet-Bix and no Milo is one outcome. So I just go to my tree and I find the right bits. So no Weet-Bix is here and no Milo is here. So no Milo and no Weet-Bix is going to equal 0.27. And again, that's come from 0.3 times 0.9. Lastly, we can find the probability that I have Milo by looking at both the situations where I have Milo. So I either have Milo with Weet-Bix or I have Milo without Weet-Bix. So PM is the probability of M and W plus the probability of M and not W. So what I'm doing now is that to find out that Milo probability, I'm adding up all the situations where I have Milo. So the probability of Milo and Weet-Bix is this first one here, and the probability of Milo and no Weet-Bix is this one here. So that works out to be 0.56 plus 0.03. Okay, so the way I do it, I do my multiplying on the tree and I put those numbers in here. You could do it just separately in this answer here. So you could go like this, 0.7 times 0.8 plus 0.3 times 0.1. So there you go. That's an introduction to trees. Pretty slow. Sorry that it took so long, 9 whole minutes of your life. Make sure you do heaps of practice at these. They come up all the time. Actually, they come up in real life and they also come up a lot in maths tests. Have a lovely day and I will see some of you on Google Meet soon.